The sky's gaze, the GPS satellite revolution. In the vast and silent stage of space, orbiting at an altitude of about 20,200 kilometers above our heads, a constellation of satellites dances around Earth in a perfectly orchestrated ballet. Invisible to the naked eye, these sophisticated machines form the backbone of a technology that has radically transformed the way we live, the way we move, and how we interact with the world, the Global Positioning System, or GPS. But before we dive into the wonders and the vulnerabilities of this innovation, it's crucial to understand the journey that brought us here. A saga of human ingenuity, driven by military needs, and transformed into an essential tool for humanity. The story of GPS didn't start with digital maps or navigation apps. It began in the heat of the Cold War, in the quiet tension of the space race. In 1957, the launch of Sputnik 1 by the Union of Soviet Socialist Republics shocked the world and sounded an alarm across the United States. Scientists at the Applied Physics Laboratory of Johns Hopkins University, who were monitoring the satellite's radio signal, noticed something unusual. The frequency of the signal changed as Sputnik moved closer or farther from them. It was the famous Doppler effect. That seemingly small observation sparked a revolutionary idea. If it was possible to determine the exact position of a satellite, then it should also be possible to determine the position of a receiver here on Earth, using satellites with known positions. That insight planted the seed for what would become the transit system, a direct predecessor of GPS, developed by the United States Navy. Launched in 1960, transit was primarily used to guide nuclear submarines, ensuring they could launch their missiles with accuracy. Though primitive compared to today's GPS, requiring hours to fix a position and working only at certain intervals, it proved the concept and laid the foundation for something far greater. The real breakthrough came in the 1970s, when the US Department of Defense began developing a more robust and truly global system. The need was clear. The military required a navigation system that was precise and reliable anywhere on Earth, regardless of weather or terrain. And so, Navstar GPS was born, short for Navigation Signal Timing and Ranging, Global Positioning System. This ambitious project brought together some of the brightest minds in engineering and physics, who faced monumental challenges to create an integrated system of satellites, ground stations, and individual receivers, all working in one cohesive and precise network. The first test satellite, known as Block Y, launched in 1978, marking the dawn of a new era. Although GPS began as a military project, a tragic event in 1983 changed its destiny forever. Korean Airlines Flight 007, a civilian aircraft, was shot down by a Soviet fighter jet after accidentally entering restricted Soviet airspace. 269 people lost their lives. In response, US President Ronald Reagan announced that the GPS system would be made available for civilian use. That decision democratized access to precise location data and unlocked a flood of applications, far beyond what its creators had ever imagined. Atomic precision, how GPS works at the heart of each GPS satellite, are ultra-precise atomic clocks, usually 4 for redundancy, so precise that they drift by less than a second every hundreds of thousands of years. These clocks are the heartbeat of the system, the primary source of its incredible accuracy. GPS satellites orbit the Earth in 6 distinct orbital planes, with 4 satellites in each plane, making up a full constellation of 24 operational satellites, plus a few spares. This setup ensures that anywhere on Earth, at any given moment, at least 4 satellites are visible to any receiver, and that simultaneous visibility is the key to positioning. The core principle behind GPS is called trilateration, a method of determining an object's position based on the intersection of spheres. Picture this: Each satellite continuously broadcasts a radio signal containing two critical pieces of information: the exact time the signal was sent, based on its atomic clock, and its precise position in space, known as ephemeris data. When your GPS receiver, whether on your phone, your car's navigation system, or a dedicated device, picks up those signals, it does something extraordinary. It measures how long each signal took to reach it. Since these signals travel at the speed of light, about 300,000 kilometers per second, and it knows the time each one took to arrive, the receiver can calculate the exact distance to each satellite. Think of it like a massive distance puzzle. If you know you're 10,000 kilometers from one satellite, you must be somewhere on the surface of an imaginary sphere with that radius. If you're 15,000 kilometers from a second satellite, now you're located somewhere along the intersection of two spheres. With a third satellite, the spheres intersect at only two possible points, and then comes the fourth satellite. It resolves that ambiguity, pinpointing your three-dimensional position, latitude, longitude, and altitude. But there's more. That fourth satellite also corrects any error in your device's internal clock, which isn't nearly as accurate as an atomic one. Accuracy is everything, and even the tiniest error can be disastrous. A timing error of just 1/1,000,000th of a second can throw off your location by as much as 300 meters. That's why the atomic clocks on board are absolutely essential. But time isn't the only enemy of precision. The Earth's atmosphere can slow down GPS signals, and tall buildings or rugged terrain can cause the signals to bounce, a phenomenon known as multipath error. To fight these distortions, GPS incorporates highly advanced correction technologies. Ground control stations scattered around the globe constantly monitor the satellites. They calculate subtle changes in orbits and signal behavior, and send those corrections back to the satellites, which then include them in future broadcasts. On top of that, modern GPS receivers use sophisticated algorithms and can connect to other global navigation systems like Russia's GLONASS, Europe's Galileo, and China's Beidou. This concept of combined systems is known as GNSS, the Global Navigation Satellite System. By blending data from different constellations, both accuracy and reliability improve dramatically. In essence, each GPS satellite is like a beacon of time, sending its signal to the world, and your receiver is a cosmic codebreaker. Every fraction of a second, your device listens to those whispers from space, measures distances, and triangulates your position with near-invisible elegance. It's a marvel of modern engineering, working silently, but with a deep and constant impact on nearly every aspect of our lives. Silent and essential, GPS and its role in humanity. What began as a secretive military tool has blossomed into a technology that now touches every fiber of our society. The usefulness of GPS to humanity is vast, multifaceted, and it goes far beyond simple navigation. It's an omnipresent tool, operating quietly in the background, enabling everyday tasks, and powering entire sectors of the global economy. The most obvious and widespread application of GPS is, without a doubt, navigation. Our smartphones have become true pocket guides. Apps like Google Maps and Waze lead us through unfamiliar streets, warn us about traffic, and find the most efficient route to our destination. It eliminated the need for paper maps and manual compasses, but it went further than that. It optimized travel time, reduced fuel consumption, and made our journeys safer and more predictable. In aviation and maritime navigation, GPS is more than just a convenience. It's a vital safety system, allowing aircraft and ships to stay on precise courses and avoid collisions, especially under low visibility conditions. In transportation and logistics, GPS has revolutionized fleet management. Companies can now track their vehicles in real time, optimize delivery routes, cut operational costs, and significantly boost the efficiency of their services. Delivery trucks, taxis, buses, even trains, all benefit from the pinpoint precision that GPS provides. But perhaps no industry has benefited more quietly and profoundly than agriculture. So-called precision farming uses GPS to guide tractors and equipment with centimeter-level accuracy. This technology allows fertilizers, pesticides, and seeds to be applied with surgical precision, minimizing waste, reducing environmental impact, and increasing the productivity of every inch of cultivated land. Farmers can generate detailed maps of their fields, identify areas that need special attention, and ensure every centimeter is treated with maximum efficiency. In the fields of engineering and construction, GPS has become an indispensable tool. Engineers and surveyors use high-precision receivers to map terrain, plan projects, and position structures with millimeter accuracy. Buildings, bridges, highways, all constructed to exact specifications, saving time, reducing costs, and ensuring safety and structural integrity. In public safety and emergency services, GPS is absolutely critical. Police vehicles, ambulances, fire trucks, all rely on the system to reach emergency scenes quickly and save lives. Even emergency calls, like 911 in the United States, are enhanced by GPS technology, allowing dispatchers to locate callers and send help with near-instant accuracy. In science and research, GPS is a treasure trove of data. Geologists use it to monitor tectonic plate movement, predict earthquakes, and study crustal deformation. Oceanographers track buoys and ocean currents. Meteorologists use GPS signals to refine weather forecasts and analyze atmospheric structure. Even wildlife biologists track animals with GPS collars to understand migration patterns and behavior, helping conservation efforts around the world. And beyond that, GPS supports a wide range of modern applications, often invisible, yet absolutely vital. Geocaching, a modern-day treasure hunt powered by GPS coordinates. Sports and fitness, smartwatches and running apps track distance, speed, and performance. Food delivery and e-commerce. Food delivery and e-commerce. Logistics systems rely on GPS to plan efficient routes and provide accurate delivery times. Mining industry. Heavy machinery is guided by GPS for precise excavation, drilling, and transportation operations. Energy sector. GPS supports the monitoring of pipelines, power grids, and complex electrical infrastructure. In short, GPS has transcended its military origins and become an invisible, yet essential, global infrastructure. It's not just a convenience, it's a driver of progress, a pillar of safety, and a tool that continues to shape and enhance our existence. In ways we often don't even notice, it stands as irrefutable proof of humanity's ability to innovate, to turn complex challenges into elegant solutions that elevate the quality of life for billions of people around the globe. But what if it all disappeared? The silent blackout, the impact of a GPS shutdown on life and society. Imagine for a moment a dark dystopian scenario, not fantasy, but entirely possible in a world that's increasingly interconnected and vulnerable. It wouldn't be a nuclear war nor a meteor crashing into Earth, but something far more subtle and far more insidious. A complete GPS signal blackout caused by catastrophic system failure, or worse, orchestrated by a hostile nation. What if this invisible yet vital infrastructure was silenced in an instant? The impact would be immediate, overwhelming, irreversible, a cascading collapse rippling through every corner of modern life. The first victim? Navigation. Millions of autonomous vehicles would suddenly shut down, frozen in time. Delivery trucks would become lost on the roads, unable to find their destinations. Airplanes, even those with emergency inertial navigation systems, would face monumental challenges. Flights would be grounded. Delays would skyrocket. The skies would become zones of uncertainty. Cargo ships, now drifting without reference points, would lose the ability to stay on course. The risk of collisions and groundings would rise dramatically. Global logistics would collapse. In just a few days, supermarket shelves would go empty. The supply chain, once fine-tuned by GPS, would fall apart like a house of cards. But the disaster wouldn't stop there, because GPS is not just a positioning system. It is, above all, the world's master clock. The astonishing precision of the atomic clocks on board GPS satellites is what synchronizes critical infrastructure around the globe. Without that synchronization, power grids would begin to fail. Energy plants would no longer coordinate generation and distribution. Massive blackouts would sweep across entire cities. Darkness would consume the world. Communications severely affected. Cell towers, data centers, global servers all depend on GPS time synchronization to function with precision. Without it, phone calls would drop. The internet would become unstable, then disappear altogether. Global communication would fragment. Nations and communities would be cut off. E-commerce would grind to a halt. Online banking would freeze. Financial transactions would stop, and the financial sector in particular would suffer a devastating collapse. Stock trading, high-frequency transactions, even ATMs, all rely on ultra-precise timestamps. Without them, financial markets would crash. Losses would be incalculable. A full-blown global financial meltdown could unfold. Modern agriculture, so dependent on precision farming, would be devastated. Without exact guidance, tractors, harvesters, planting machinery would become useless. Productivity would plummet, food shortages would erupt in waves, and hunger would once again haunt entire regions of the world. The planet at risk emergency services pushed to the limit. Calls for help lost, ambulances without routes, firefighters and police disoriented. Response times would tragically increase, and with that, needless lives would be lost. National defense neutralized. Smart missiles would fail. Recon drones would lose their way. Military operations would be blind and uncoordinated. Without GPS, an entire country would be vulnerable, blind, disorganized, defenseless. The impact on society would be catastrophic. What once seemed like just a digital convenience reveals itself as the invisible pillar of modern civilization. A GPS blackout would not be just a technological failure, it would be an existential collapse. Panic would spread quickly as connectivity and basic infrastructure began to fail. Disorientation and frustration would lead to social unrest. Everyday life, where we rely on GPS for everything from finding a restaurant to booking a ride, would become unrecognizable. Trust in institutions and in technology would be shaken beyond repair. This scenario, though dramatic, serves as a stark reminder of our growing dependence on systems that, for most people, are invisible and taken for granted. It underscores the importance of developing robust backup systems, diversifying positioning, navigation and timing sources, also known as PNT, through other global navigation satellite systems and technologies based on inertia or terrestrial radio signals. And more than ever, strengthening our resilience against cyberattacks and intentional interference. GPS, this marvel of engineering that connects us to the universe and guides us on Earth, is a testament to human ingenuity. But its fragility, vulnerable to attacks or failures, represents a critical weakness for modern civilization. It's a call for caution, a reminder that, while we look to the stars for guidance, we must also protect and strengthen the foundations of our own existence. Because in the end, the light that guides us from the sky may be the very same light that, if extinguished, would plunge us into the deepest darkness. If you enjoyed this video, like, share, and subscribe to the channel. Hit the bell so you never miss a journey through the curiosities of the cosmos. I'm Commander Marcos, and you're watching Star Chronicles, where every shadow of space hides a story. Thank you for watching, and see you at the next stellar curiosity.